Welcome everybody. We're just going to wait maybe 2 more minutes for more attendees to show up, and then we'll kick off. Hi everyone, welcome to the third Localtalks session. We're so psyched that you are here and you could carve out time out of your evening or your day, wherever you are, to attend this session. My name is Sarah Kukirizandagire, and I'm a graduate architect, and I will also, like I've been for the past 2 events, I'll also be your host and moderator today. This is our last talk of the year, and it will actually also be the last talk that I'll be a part of. So I'd like to take a moment to genuinely thank you all for showing up each time and cutting out the time out of your schedules to attend these talks about conversations that relate to conversations about green design. For those who are new to this space, Localtalks is a series of quarterly events. These talks were curated with the aim of creating an open forum for the exchange of ideas, honest debate, and knowledge sharing, as you're going to see this evening. These sessions are meant to bring together people who are interested in and passionate about all sorts of green design, architecture, and construction in East Africa, and actually all around the world, because over the past 2 talks, we are excited to say that we've been getting an audience from over 13 countries each time. So actually, if you can, go ahead and let us know where you're tuning in from in the chat, what city or country you're tuning in from. So before introducing our speakers, I'd also like to take this time to thank the Uganda Society of Architects for supporting this event. Particularly architect Kenneth Amasimire, who plays a key role in promoting these talks in the various architecture circles here in Uganda. We are grateful for your support. I'd also like to note that this webinar is being recorded and it's also being live streamed on the Localtalks Facebook page. So in case you miss anything, you can always catch the replay on the Localtalks Facebook page, but we'll also upload it on YouTube and send you an email with that information. For this evening's event, we are going to dive into building with straw, and we are hopefully going to get an answer to the question that was in our event poster tagline. Is this a suitable construction material for East Africa? Our lineup today has two experts who have been researching and using this material for a total of 34 years combined between them. That's Horn and Eckardt Dauck. So Andy is a qualified professional architect with over 24 years of experience with the design and construction of natural buildings. He also established his own architecture practice in 1998 called Eco Design Architects and Consultants in South Africa. And Eckhart is the founder of Zero Carbon Design, he's an entrepreneur and impact investor who 10 years ago started to introduce green building technologies to East Africa. And he has created a local value chain to produce sustainable building materials, create climate responsive designs, and build turnkey structures here in East Africa. So both our speakers will present for about 20 minutes each. And after that, we shall have a Q&A to keep the discussion going. If you are watching on Zoom, feel free to drop your questions in the Q&A box, not the chat, the Q&A box. And if you are on Facebook, do leave your questions in the comment section and we'll answer as many as we can after this presentation. So Andy, thank you for being here. You can go ahead.
Okay, am I on there?
Yes, you are.
Okay, let's just get this to full screen. So there we go. Okay. Right. Just to briefly say, yeah, my focus and particularly around straw bale building, obviously it's counterposed to our conventional, very carbon intensive technology. And in South Africa, we rely on coal mostly for energy. So all that cement that we use in construction is coming from there. And the other point is just that as a point of departure, as a designer, is to try to be conscious of the chain of events from where the extraction of the material to eventually to construction, manufacture, construction, and then demolition potentially or reuse. And so it's trying to understand where do these things come from, what impacts are we having in totality on the environment, on society, on the economy, and not just on necessarily micro scale, but trying to understand things a bit more on a macro scale. So, and then historically, this country, we have a lot of natural building. All our kind of so-called all our settler buildings, the very early ones, 300-400 years back, they're all made of mud brick, and the one on the top left there you'll see is made of light clay straw. So that's our oldest one that I know of clay and straw construction. More in Southern Africa, I come from Swaziland. There's a lot of clay buildings, and but they kind of don't last because generally foundations, and if they don't have good foundations, then as all sort of earth buildings, then they have problems. So straw bale building, like earth construction, is the basic rule there is you want these buildings to last. You need a good pair of boots and a good hat. So a roof and good foundation of something harder than mud that's not going to suck the moisture up. So to quickly go through Strawbell building, the kind of history overview, Strawbell buildings are now over 100 years old, and kind of basically they originated in Nebraska in the States with the advent of the baling machine, where the grasses were baled and materials were so scarce that it was just an obvious thing to use the grass, and they baled and then they ended up getting plastered. They were originally not even intended typically as permanent structures, but some of these things survived. And then that's when some people kind of discovered that in the 80s, that kind of started a revival, and people wrote books, and the next thing there was a kind of Strawbell building revival, and that took off. You can see kind of all over. And so, you know, even in Alabama, which is very hot and humid, I put the slide in, there's a building there that's, you know, 82 years old, and it's a national monument, and it's made of straw bale, and, you know, it's very hot and humid there. Australia, you know, so it's, as I said, it's kind of taken off, and you get straw bale buildings now all over the world, in all kinds, from rural to urban settings. In France, they've been building 7-8-story apartments in straw bale construction, infilled in between conventional, you know, concrete frame construction. So, and then if you look at sort of more locally, the earliest one that I know is 1994, and there have been various structures built, mostly by owner builders, some by architects, and of various levels of quality and so on. And, you know, wine cellars and scale, mostly domestic though. And then just to say, yeah, there's a lot of approvals. So 30 different municipalities have given approvals around the country. And I've recorded, that is, that I can verify, with over 55 different buildings. So if you look at straw, it's an annually renewable resource that could be generally from grain production, but it could also be dried grasses, but it's the stalk part of the cereal grain typically. So we're talking wheat or oats or barley, rye, rice, any of those kind of straws, and that's typically a waste product. It's annually renewable, these crops, and often, you know, in South Africa and California and these places, straw is often burnt because the farmers kind of can't deal with it. They want to prepare their fields, and so it also results in a lot of pollution when that straw isn't used. And we have it's a huge potential as a resource. In this country, we produce, you know, about 3 times more straw that, you know, in terms of building material, that we produce as material, if you follow my what I'm saying there. So, you know, we could only really build about 250,000 homes, maybe 300,000 homes a year in the formal market with formal materials. Yet we produce enough waste straw to build over 1 million homes. And that was a study done by a PhD engineering student. Then you look at the energy efficiency. You know, it actually makes concrete block look and brick actually look pretty antiquated, pretty backward. So you're getting in the R values across the thickness of around 7 to 8 R, you know, across the width of the walls. The Strawbell is fast to construct, and it, you know, with much reduced environmental impact. And, you know, in terms of building, it's fairly simple skills, and you get all ages. You know, it's a kind of participatory process, so you get generations of families, you know, grandchildren, parents and grandparents, all building their homes sometimes. And you can involve local communities and so on. So it's got a very fantastic participatory aspect to the way you build. And then you look at its performance. It's incredibly fire resistant. So these are German standards testing, where they resisted 2 hours at 1,000 degrees, and you only had an 8-degree temperature difference across the wall. So I mean, you don't find many many materials that will perform like that. And because you kind of brace it typically, and you have ring beams and so on, it's a it's actually quite resistant to earthquakes when you compare it to typical construction. You've got to take care of the rain and so on, and provide drips, and then that's kind of the moisture is its kind of biggest thing you've got to look out for. So good roofs and so on, overhanging roofs help a lot. And then the toe up, so it should be higher than the bale, should be higher than the floor level. Those are just dimensions. You get 3-string and 2-string bales. You've got to retie them like bricks. And then these are different base plate kind of details where you put the bales. You can see these drawings, they're showing the bales on edge. You can also build them with them on flat, so on the edge or on the sides or across. And then these days we'll put a kind of ladder plate. You can see the toe up plinth in stone, and then a ladder plate which protects the bales at the bottom, creates a capillary break, and then an attachment point for structures, for window and door supports and so on. This is just some termite proofing. So if you've got termites that are straw eating in your area, you need to what, then this can be an issue. So one of the things you can do is put a full metal capping across the base, but then that needs all the punctures and everything need to be sealed with gaskets and solidly sealed, because termites can get through just about anything. We also, just on the termite thing, we also use diatomaceous earth, and then you don't need to do this whole capping. So that's also very effective. And then basically structurally, you either have a load-bearing structure, so that means the bales actually take the weight of the roof, and you do that by creating a timber ladder beam around the top and tying that down, strapping that ladder plate at the top down to the foundations, so that and then you attach your roof to that, so it can't the wind can't take it off. There you can see a sort of strapping tool, nylon strapping, 1-ton nylon strapping, and the bales kind of going in, the ladder plates and so on, and then you can see the roof. So a very simple kind of structure, minimal materials, but obviously the vulnerability is from the top. So you've got to really take precaution, before you can get your roof on, and you will have compaction. So you've got to pre-compact. That's why you have that strapping. So you will have settlement. So you've got to also kind of look at that. And then, but more commonly, you'll have a non-load bearing system. So this is an example where there's some masonry pillar work, which creates some bracing in the structure, and then timber support. So you typically would panel each bale. Every sort of 2 bales is 2.5 is sort of maximum length of bale before you would have some sort of bracing support, timber ladder or pole or something. And there you can see the bales going in, clay around the openings and so on, and then the plaster work on. This is a more solid plaster, and we are doing what's called cobbing. So it's a stiffer mix of clay, straw, and we're pushing that into the bales there. But this is very laborious. It gives you a very solid surface than just smearing the plaster on, which can be very time consuming, and less satisfactory in terms of how solid the wall is and the plaster adheres. So you can see the conventional way you would cob is you kind of mix it up. This is very basic technology, and then you pack it directly onto the moist wall. So it's a kind of extension of that technology. You can see that's a typical way you would cob. You have these sticks, and you push each kind of lump of cob into the layer below, so it becomes a sort of uniform, homogeneous material, and so it's very sculptural. And so this sort of naturally aligns itself with straw. But saying that this process of putting a kind of solid, trying to get a solid key on your plaster, that's an earth plaster cob, is very time consuming. And it's difficult on a sort of spongy surface. So there's kind of, you can see this evolution of technology that I've kind of been through different, now we use, as I said, this ladder plate. And then the key technology, sort of innovation I've come up with is this kind of pre-coating. So there you can see we put the bales up dry between frames, and there you can see, then we unstack them once they've all been fitted tightly. in a very orderly fashion. So row by row, we know where we're going to put them back. You can see them, those have been packed out on inside out of any potential thing from rain. You don't want to get them wet. And then you can see mixing up some soil into a kind of runny mix. Then you take the bales and you pre-coat them in this kind of runny slip. So it goes in very far. You work that runny slip right in. And there you can see it sort of mixing up. There's a workshop with 3 different dip tanks dipping baths for the bales with the clay. There you can see again 3 different. So with workshops, you'll typically have a number of these baths, so you can facilitate more people, and you can kind of rotate the mixing and so on. There you can see we use these cobbing sticks, and you work that sort of slip. It's a very yogurt sort of runny mix, yogurt kind of consistency, and we push that clay right into the surface that we're going to plaster. Then we put them back in their order and let them dry. So they so you've got to kind of watch. Sometimes we use a stiffer mix if it's like this. It was more humid. If it's very hot, you'll use a runnier mix. So it's all about timing. So you so that you're basically trying to get the bales almost dry, almost hard, but still tacky when you start stacking them. So you can see there they're ready to go on, and then you start stacking them and working that surface. So in the same day, they become fireproof, waterproof, and with a very solid plaster on. So you save weeks of time, and you get a sort of combination between the solidity of a wall, like a cob wall, because they don't sound hollow anymore. They become very firm and strong. And then you have all the insulation of straw. You kind of, from the bars, you'll get a sort of, you'll take out that stiffer mix, and then you already use that. It's kind of like a ready-made cob. You half dry it off in the sun, and then you use that to stack back in. You can see we stake sometimes horizontally. We cut slots in, and you also knock stakes in to sort of pin the bales together. There you can see stuffing straw in where the bales maybe didn't fit so well. There you can see it's working that surface to push the cob further in, and you kind of work the surface so that it hardens, and you can flat it off and kind of get a workable surface. And you can see all the cobbing holes, increasing the surface area as for drying and hardening at the same time. There you can sort of bashing that one's wasn't going in so well, it's a bit tight, and so on. So then you can see the walls go up, and they're rock solid, and in the sort of same day. So just flying through these slides, sorry about that. And then just sort of a related technology, but I think may be more applicable for Uganda, where you may not have baled. You can make your own kind of baling compaction machine or device, as they did in Pakistan. There was some Strawbell buildings done there, and the guys had rice straw but no baling machines, and they kind of made their own compaction to device to make their own bales. But otherwise, you can do what's called light clay straw. It's more timber heavy. The walls are typically thinner, and you make a formwork and you mix the clay and straw together into panels. There you can see the slip. So you make a slip. You let the thing, you mix up, you let it slump, so you leave it overnight. Then you sort of tamp it into formworks, and you take the formworks off. You left with a kind of very rich straw mix. So there you can see in a more finished building, or where the light clay straw is dried out more, you can see how it fills the wall. You have ladders every kind of meter center or so. And then just lastly, the plasters with Strawbell, you've got to have a breathable plaster. So we're typically using a kind of lime dung plaster, lime being stronger, but you can also use a variety of fibers from newspaper, soaked newspaper. As a dung, you can do glue sizing for internal earth plasters. So there's a huge variety in the way you can get your finishes and plaster. You can see this is just a simple earth plaster. You can see how it can go straight onto that hard, firm kind of cob surface. There you can see with very fine chopped straw. Yeah, and then that's just a lime plaster going on. You can see the lime takes longer to cure. You don't want it to dry out too fast, so you've got to kind of wrap it up and slow the drying process down. Yeah, that's about it. So There's some finished buildings. And then just lastly, again, to say, yeah, it's, and you know, buildings, yeah, as I said, and Strawbell building really give the opportunity for much more than simply physical buildings, but also open up all sorts of opportunities in terms of the process of building and how that can, you know, form communities and you know, improve local self-reliance and skills and build local economies. So I think it's a fantastic way to build. It'd be very interesting to see how it would perform in Uganda. So yeah, I think I can leave it there. Is that good?
Yep, thank you, Andy. I think you can stop sharing the screen now.
Yeah.
Great, thank you for that. We're now going to transition to Eckhart, so if you can have that talk. I think you're muted.
Yes, I'm sorry. Yes.
Oh, there you go. Yeah, we can hear you now.
Yes.
Thanks.
Sorry, I will share my presentation. There's a problem.
We are seeing your presentation well, Eckhart.
See already. Okay. So I have a problem. It's going to the first slide. So thank you very much, Sarah and Felix, for the invitation, and good afternoon, everyone. I hope you can now see the presentation. And Andy, thank you for your presentation. I found that really interesting, and there are probably a number of things we can talk about in the future. So I will be here today with my colleagues, Peter Dissel, he's our engineer, Agnak Tadese, he's one of our architects, and our production manager, Felix. They are now joining from Addis, from Kampala, and from northern Uganda, and I'm currently in Berlin because of the COVID problem. Yes, we will be happy to answer more questions after the presentation. That's why all of us are here. I do the main part of the presentation and would like to start a little bit with the history of strawboard. It has been developed in the 1930s. There are over 250,000 buildings that were built with strawboard, mainly in Europe, but also in North America and Australia. It has mainly been used for roofs, for partition walls, for cladding of external walls and flooring systems. I started to get involved in 2009, together with a friend of mine, an architect, Klaus Fischer from Germany, and we were looking for a technology that is scalable, that is environmental and climate friendly, and could be also introduced into Africa and to East Africa, and we found this strawboard. We started with a lot of research with a number of universities. So the next big step was in 2012 when we started to implement an R&D project together with the Bauhaus University from Germany, the ETH from Zurich, Switzerland, and the EIABC in Addis Ababa that was in Ethiopia. It was funded by the DIAD. And the result was the construction of a two-story building. You see that second picture there. That's the building. It's monolithic. It's made just from the strawboard. It's load-bearing, 2 stories. And it has been used by the university since 2012. It gets monitored from time to time, so there have been no issues, although there are termites, but they don't attack the board. And Andy mentioned that earlier. The board hasn't settled, and the professors have tried all kinds of very innovative finishings to protect it from the rain. For instance, you can see on this side they used a very thin metal foil. They made shingles out of it. On the opposite side of the building, they used cut inner tubes from tires, from car tires. And all that works well. I'm actually surprised, but I'm happy to be here today to say 8 years later, it's all working. So in 2015, I opened up a first factory in Africa, in Kigali, in Rwanda. And we continued our research, which was funded by Fonerva. We did a lot of focus group interviews, worked with a number of architects and engineers there, and also built some model buildings. In 2018, we then set up and opened up a first factory in Uganda, in northern Uganda. And that last picture there shows that a little bit. We have a partnership in Uganda with Malteser International. That's a German NGO. They asked us to come to Uganda, to the north, because they work a lot with the refugees in a rhino camp and other camps. And there are a number of buildings required, mainly school buildings, hospital buildings, and so on. So to implement that, we set up a foundation, the Impact Building Solutions Foundation, as a social enterprise. It's registered in Uganda. We want to create local value chains, and that applies to farmers that supply the straw, but also to contractors and builders, architects, engineers, and so on, so that we really have a lot of people participating in this, gaining from this, helping to make this part of the typical building materials being used in the region. And it is really our objective to scale this up, and not just for us, but together, because there will be a lot of construction going on in the next years in Africa. The largest cities will be there in 2050. So we need to find alternative materials, and I mean materials, not just this, but anything we can find that can be locally made, that environmentally and climate friendly. So that's the third point, to promote and produce environment and climate friendly materials. And for that, we have set up a factory in northern Uganda, which I will show you in a minute. This is what we are talking about, the strawboard. You see on the pictures on the right-hand side, that's a complete board. We have a continuous production process. So we make it the lengths, we cut it to the lengths that you need for projects. If we have 2.85 meter ceiling height, we make the panels 2.85 meter, and we don't have any waste on the building side. In the center, you see a number of boards stacked. So we have a production capacity there for about 2,000 houses per annum in Uganda. And on the left, okay, so I hope you can see me now.
Yes, perfect.
Yes. Okay. And on the left is a panel that we cut through so that you can see the thin layer of recycled kraft paper on the outside and the core of compressed straw. And I will come to what's in there in a minute. So the width of the panels we are producing is 800 millimeters. They are 58 millimeters thick and up to 320 long. depending on requirements. We have produced panels that are 5 meters 60 long, but that's then a special order. So the machine can produce on a regular basis up to 3 meter 20. We can vary the panel weight depending on the properties that our projects require, between 18.5 and 24.5 kg per square meter, which translates into a density of about 318 to 422 kg per cubic meter. Yes, and we are producing according to a British standard. We also have a Rwandan standard that's similar, and we are working on the Ugandan standard at the moment. So one key thing is the straw supply. We use in Uganda, we use rice straw from local farmers in Noya district. And as Andy already said, it's a waste byproduct of the production, or in this case of rice. And the farmers there, the larger commercial farms actually burn it. The smaller farmers, the smallholder farmers, they usually throw it away. So it's not being used like wheat straw or other straw for animal feed or other purposes, and at least not in that region. To give you an idea what we can produce per acre per hectare or 2.5 acres of rice field, that grows enough straw to produce or to build 250 square meter houses per year. So one every 6 months. And that is a really interesting thing to look at. In Uganda, there's enough rice straw to produce panels for about 40,000 houses per annum. And that already shows you that this is not a project that we want to do alone. That is a project that we want to do with partners and anyone who's interested and wants to join. So this shows you our production facility in the north of Uganda. When the factory building, and then you look to the right, that's the straw intake, where in this case, small bales from smallholder farmers are being fed. But we also use big round bales from the commercial farms. And I think maybe I forgot to say that we started with the big commercial farms because the straw was readily available and they have the ability to process it, to bale it, and to supply it to us. But we are very much engaged and have just finished a social economic study with the smallholder farmers to really get them on board and to organize this. And Felix, who's on the call today, he's in charge of that, and he has a lot of experience with that. He's done that before for us in Rwanda, so that we get a big chunk of our straw from the smallholder farmers, and they have an additional income. So on the third picture, you see the press. So the straw is first loosened up, then it goes into a chute, into a press. You see the straw core in the middle, and the kraft paper, the recycled paper coming in from the top and the bottom. We do not add any chemicals to the straw. We heat it between these beds. We heat it to about 200 degrees Celsius. And the only glue we use is the glue to glue on the paper onto the straw core. In the next picture, you then see how that comes out of the machine. This is the start of the production. Usually you would just see a long, about 40 meter long slab that then gets cut at the end, and you see the end seal unit there. There's a saw that cuts it while it produces into the lengths that we need for the projects, or you need for the projects. Yes, when it comes to sustainability, first of all, it's environmentally friendly, especially when we compare it with roadside bricks. And that in northern Uganda, you know, we have a problem with clear cuts there. A lot of the timber has been cut, and it's illegally being cut and not replanted, so it's not sustainable. We try to include the current value chain of roadside bricks into our value chain, so that we offer people who are in that business to join us and deal with strawboard instead. But we don't need any water in the production process. We don't need wood to fire, and we have this rapidly renewable raw material, rice straw, that we can harvest twice a year. When it comes to climate-friendly solution, then there has been a study that was done together with Fonerva and IFOI Institute in Germany that looked at different materials produced in Rwanda at the time. So these are numbers for Rwanda, but it shows you the greenhouse gas balance, including carbon fixation for the strawboard, which is about 21 kg savings compared to cement blocks. And these are modern fired bricks. These are not roadside bricks. Roadside bricks are 2.5 to 3 times as bad in the performance when it comes to this. So our panels can be reused or recycled. When you have a building that you take apart, you can use the panels that you can recover in a new construction. Panels that break, we take back and we shredded them and then reintroduce them into the production process. So up to 10–15% of the material that we feed into the machine can actually be old panels that we recycle. I talked already about the waste on the building side. Because we cut the panels in the factory, in the production process to the required lengths, the waste on building site is greatly reduced. This very quickly how a wall assembly looks like. So this is for a load-bearing wall, and it also shows some corner units. You can look at that in more detail probably later. But when we build load-bearing walls, we use 2 panels. So our wall is 12 centimeters thick. And we use a U-profile, metal U-profile that we fix to the foundation. And then install the panels within these U-profiles. On top, we have a timber, an FSC certified timber top tie, and we use a super latex waterproofing at the edges where it's required, and I can show you that on some pictures in a minute. So mainly on the bottom, on the top, and when we have cutouts for doors and windows. These walls then are, we have different finishing options, and also what Andy said about lime plaster. That is something we are just discussing with Felix actually, because we've used this in Germany, but on internal walls with the strawboard. We've also used clay with the strawboard on internal walls here when we did renovations of old buildings from 1560 and so on, and it works really well. And I would like to introduce that also together with Felix there in Uganda. So what we do at the moment is either we have a cladding with a metal sheet and timber studs behind it, or we use a waterproofing paint, then a chicken wire that we nail against the slab. Then a rough cast, so it's a normal cement rough cast that everyone uses in the region there. They know how to apply it, and then paint it on top of that. With that, we have very good performance experience, so it lasts. There are no cracks there. The chicken wire helps a lot to make it work, but it's a reliable and good finishing on the inside. You're pretty much free what you want to do. Some cover it with wood, some leave it like it is, so it doesn't require any cover. It has this very thick 460 gram craft paper. So there are a number of buildings that didn't get painted or didn't get finished on the inside, also to save money. The basic finish is a primer and then a paint finish, but you can also fix tiles to it. Or anything else you're interested in. And just in that context, there are apartment buildings here in France and in Europe that were built in 1958, multi-story, and the complete internal partition system, including the bathrooms, is made of these panels, and they are still functioning, and the bathrooms are still the bathrooms with the panels that were installed in 1956. So we have experience about the longevity In Germany, we have a big convention center that was built in 1965. The complete roof of 7,500 square meters is made from this panel. And now over 50 years later, it's still on there and there are no issues. So this shows you some pictures of the construction process. So the first, we cut the straw just like wood. You see he has a circular saw there. We use it for walls, for floor slabs, for heat insulating ceilings, and so on. In the center picture on the top, you can see panels that we prepare in the factory. So for a number of projects, we actually prefabricate all the panels in the factory. So we cut out the doors, we cut out the windows. You can see a little gray paint that is this special waterproofing paint that we put around the cutouts, and then deliver it numbered to the building site. So to then set up all the walls for a building like that is about 200 square meters would probably take about 4 days. Yeah, a team of 6. So it's a very fast, very accurate construction technology. On the right-hand side, you see the building that was built in Addis, the first one in East Africa by students and professors. Then when you go down, there's a 3-story building that's actually load-bearing, but that was just a pilot building. So when it comes to buildings we build for clients, if it's more than 1 story, we use a wood frame or whatever frame, reinforced concrete or steel frame. One thing in the center on the bottom, you see him putting these panels on the ceiling. They are very good when it comes to heat insulation. So we've done some measurements in school buildings that had no ceilings before, and measured before and after, and it was a great reduction in heat inside the classrooms. But also when it comes to the noise level, you know how it is when it rains and the rain hits the metal roofs that are typical in the region. Teachers can't continue to teach. Yeah, so both of these can be mitigated with this. It's not the cheapest version. It's not like putting a 3 millimeter plywood up there, but it is an effective version. Yes, then very important for us as part of building local value chains is also skills development. And we have been working with the GIZ and with DEG and other international donors that to do this. We've introduced on-the-job trainings for locals and for refugees. So in these pictures, you can see on the top right, for instance, that's in a Rhino camp, where we trained all these young people. And a lot of them have now already done 3 or 4 or 5 jobs with us, and have a future to earn some extra money. On the bottom left, that's a team. I just got this picture from Kakuma in northern Kenya. We're building a hospital there, so they are working there, and it's really good to see how open they are, how interested, and it's an easy technology, so it can easily be adapted. And they get trained not by people who come from Germany. We actually now have specialists in East Africa who started to work with the material in 2015 and who are now training the young and new ones. And it's a really, for me, it's a really great thing to see. And here are a couple of selected projects that we've built in the region. So in the school building on the top left with a large roof overhang, to shade it. Then on the top right, that's a building in Kenya, actually, that was designed by Mass Design, and all the walls and partitions you see there, they are made from the strawboard. Then the building in Addis Ababa, you see the different finishes that the professor used. It's a flat roof. Even the roof, everything is made from this strawboard. We would not do that in a normal project, but in this case they wanted to do this. And Agna, our architect who's online today, and also Pete, our engineer, they both were part of this project, and this was their first project with strawboard, so they have that experience for the last 8 years. Yeah, and on the bottom right, you see a typical small building that we built, and that's quick and quick to build in. So now I will hand over to Pete. He has one more slide about structural abilities of the board, and thank you very much.
Thank you, Eckhart. Peter, you're muted.
Oh, yeah, the usual problem. Hi, everyone. Thank you all for joining. Greetings from dark Addis Ababa. I just lost electricity. I hope that the internet connection is at least stable for the rest of the presentation. As Eckhart mentioned already, I'm a structural engineer working in Addis Ababa. We met in Addis Ababa when he was starting this research project at EIABC. We met at a conference, and I was very much interested in this material and asked about the structural properties. And he presented some handouts from research that was done in the 1980s and 90s, I think. And looking at the values there, I was highly surprised because it almost had the same strength as plywood, and I could not believe that really. So I was personally interested and soon joined this research project, and we did some field testing of this material, and it turned out that it was just a slight mistake with the units. So actually, it's not as strong as plywood. It's about the 1/10 of the strength of plywood, but since we were using it for load-bearing walls and even load-bearing slabs in this research project, we wanted to know exactly about this material. So ever since, we conducted several test arrays ourselves and with renowned institutes, amongst which are the Federal Institute for Material Testing of Germany in Berlin, the BAM, and these properties that I'm presenting here, they were tested at University of Rothenburg. That's a specialized university in Germany that deals with wood and wooden products. So that was an extensive test array, very professionally done, I have to say. So congrats to the students who worked on this. And we got the results that we wanted, that is bending in both directions, compression and tension in both directions, perpendicular and parallel to the fibers. We did some shear tests already, and all of which comply to Eurocode requirements in terms of statistic relevance. So these values actually are liable and can be used for structural design. Looking at them in detail, it is true that this is not a high strength material. Nobody expected that, but given the fairly thick layers of 60 millimeters compared to other wooden products like chipboard, oriented strand board, or other materials like that, it actually holds a lot of load. So especially for the load-bearing walls, I could mention it already. We're using it usually for single-story buildings so far, but experiments and prototypes show that we can build up to 3 stories entirely with straw as load-bearing walls, including earthquake forces. We then use 3 or sometimes 4-layered walls. So it is possible. It's a matter of economics. It's a matter of construction speed. But in general, it's possible, and we'd like to see that implemented on a larger scale in future. Now is that we can actually also present to the permit issuing authorities, which used to be a problem in the past sometimes. Let me just switch off my video. It looks very strange in the first place, and also it goes on the bandwidth. So for future plans, most of the material properties are, as I said, tested. We haven't done yet full-scale earthquake tests. That is an idea we're still juggling around with a little bit, though we do have the basic properties to do a solid earthquake design already, but it's always better to test more. That brings me also to the point that Eckhart mentioned earlier, that the close collaboration with several institutes in the world is also a big part of this approach, because knowledge is always good, and we can produce several bachelor and master theses, and also raise interest in the academic world for this kind of material. And there's still a lot to look at, detailed solutions, different glues, different laminations, combinations with other materials, and so on. So we're looking forward to bring this research further, but we do have the basic knowledge and the basic properties to do a solid design that is approvable by authorities already. So that's from my side. Thank you.
Thanks, Peter. So thank you so much, Andy and Eckhart and Peter, for that. I think it was very insightful. For me, it's like pretty interesting to see that, you know, it's a material that has very many strengths. And I guess the question mark is, why is it not, you know, as popular here in East Africa? But before you answer that, I would like to invite Edson Agume, who's our structure engineer, to see if he can add or ask any questions.
Thank you, Sarah. Thank you, Andy and Eckhart, for such great presentations. I enjoyed them greatly. I mean, it was very, very educative, especially for the Strawbells, for Andy's presentation, since I have interacted with Eckhart before, but I hadn't interacted with Andy. I just have to have a few maybe clarifications and questions. I think Andy mentioned that we may not have these Strawbells here in Uganda, but yeah, much as they are not much, but we actually have, even here in around Kampala, we have a facility that bales straw for animals. I've purchased them myself. And I think even in Andy's, rather in Eckhart's presentation, he has demonstrated that, you know, there are farms that are able to bear this. The question for Andy. Sorry about that. I have just a question for Andy about finishes. I like the approach on, especially of dipping these things to fast before building, to harden the surface a bit. And I was wondering whether, because I've seen so many, you have timber beams and sometimes timber joists or something. I'm wondering when you are finishing these surfaces, especially between the straw bales and the timber surfaces, are you not worried about cracks that may develop because of different absorption capacities or different adhesion capacities of these surfaces? Also, do we have, you've presented earth and lime plaster, do we have other finishing options that are maybe more modern and more conventional, and in Uganda's perspective that would be more acceptable? I don't know whether I should also pose another question to Eckhart's team, Sarah.
Go ahead.
Yeah, I like the Strawboard. It's really amazing when it comes to construction time. I mean, build a house in 4 days is quite amazing. I just have, again, one little concern about the finishes. As you know, of course, both materials need to be well protected from weather, from rain, from wind. But I'm wondering that most of the approach for this strawboard on the external surface is actually more like sealing them, vapor sealing them. Are you not concerned about the health of this material if you actually seal it on one surface? Or even if you seal it on both surfaces, I would think that the fiber may not last that long if you do that. That's it.
Perfect. I
Okay.
think we can start with Andy.
All right. So just in terms of different surfaces, so if we've got timber that is close to the surface, where, as you say, it would potentially swell and potentially cause a crack between that material. So then we would typically put a kind of mesh over the timber. So not a metal mesh. We use a fiberglass, non sort of alkali resistant mesh. So it's a plastering mesh. So as to kind of bridge that, those two materials. And then when we come to sort of windows and things, then we're careful about, you kind of create plaster rebates. So they kind of stepping in the timber where you can plaster over, because the other thing that you have is you have shrinkage of clay around, when it's wetter, it's obviously more swollen. Then when it dries out, if you just have a straight join between timber, say a timber door frame or something, and your wall, well, then that could shrink away, and then you'd have a crack between the two materials. So, there we have a step in or step out with the timber. The way we would, if we sort of pre-support the timber door or window, or it doesn't have to be a timber, it could also be an aluminium door or something. Then you would have the sort of vertical support that goes from that ladder plate at the bottom to a beam or rafter or something at the top, or a ring beam at the top, and then you side fix your door window frame onto that vertical support. So we typically frame up, or if we're doing non-load bearing systems, so non-load bearing system. So then we'd frame up all the doors and windows first, and then fit the bales afterwards, typically. So you can get everything plumb and true, and it, because otherwise, when people build the windows in afterwards, what can happen is the walls, unless they stiffened up, then you can constantly have them moving out of plane and everything. And then your other question, just about the finishes. So obviously, one thing I should mention, as I said earlier, that the moisture is a concern. It's the biggest kind of concern with straw bale construction. The reason we use clay is actually because as a pre-coating and sometimes total finish, is because clay is hygroscopic. So it sucks water out of the material. The ideal sort of moisture content of clay is drier than straw or timber. So it will, if you've put clay next to, as long as it's not on the ground where it's sucking other water from the ground where it'll constantly stay kind of wet, as long as you've prevented that capillary, got to have a capillary break between your foundation or your plaster. It shouldn't just wrap up to the wall, because that can suck water. But if you've got the capillary break, then you have this clay finish, then that's constantly, if the wall gets wet, it's going to just dry out again. And so they found, even in ancient ruins in Egypt and so on, you can have thousands of years old straw that's perfectly preserved in the clay. And that's because of, as I say, that the combination of clay really is the hygroscopic quality. So I'm a firm believer that the wall should breathe, like you're saying, the finish should breathe. That if you trap the moisture in that straw, ultimately it will rot. And if you put cement plaster on, as I've seen with many old buildings, that traps the clay and the moisture in the clay, eventually that just builds up, that moisture builds up and causes problems. So So I'm a big believer in, and lime also breathes. It's not, it doesn't have as much permeability in vapor as clay does, but it's the sort of second best. It's obviously harder, it's a stronger finish. So I'm not a big favorite of cement finishes. You can, people do and have plastered in cement, but I don't think it's sure. And if it's dry, you don't have the wall kind of getting wet and needing to dry out all the time, then it can be okay. But in the long run, I still think lime and straw are the better finishes. And obviously, if you've got driving rain where the walls are being wetted a lot of the time, as you can sometimes have in the Cape here, where storm-driven rains, then we can put a siding. We would put like a timber siding, or you've got overhangs at each level, so that you're not having these walls kind of being totally soaked up all the time with water. So it's you've got to kind of you know, design it in its context. So not every wall is going to be treated the same way, depending on how your weather and so on, and your design of your roof and all of that comes together. So I don't know if that's answered. I hope I've answered your questions.
That's perfect. Thank you. Yeah.
Yes, so Edson, you asked about the cement plaster that we use. It's not my favorite solution, but it does work. And we have, I can tell you, in Germany, there's a building that was built in the 1990s. It has the strawboard as a structural element. It was a special permit here. It has 3 layers of strawboard, so it also is very good when it comes to installation against heat loss and so on. And that is also finished like that on the outside. So we have experience with the performance over time. And as Andy said, the issue becomes an issue when the straw gets wet. But as long as we have a proper finishing on the outside, you know, we don't have this issue. We don't seal it on both sides. And I completely agree that a big advantage is that it is it lets vapor through the strawboard, and that's why I've contacted you about the lime plaster, because you know, I want to see if it works. And we've worked with it, as I said earlier, in Germany. The issue I see that you sometimes have very heavy rains with winds, and to make sure that it doesn't damage the surface, how we can prevent that. And I know roof overhangs is an option, you know, but we should look at that. If we can make it better, we make it better. But the other example I gave earlier was the bathrooms in France. I mean, they have been sealed on one side of the board since 1958, and the panel has not deteriorated. Yeah, so let's find the best solution. And we have a number of cladding options. I mean, things have been built with nice, that's why I mentioned that, nice wooden cladding. Yes, and someone who likes to do that is also Mass, for instance. They often have a wooden cladding, and they used our panel in their office in Kigali, where they then put wooden, I think, wood on top of it. But it also increases the cost. And you need special abilities to sometimes install it. And when I look at the rural areas in the refugee camps where we are, we need to, you know, apply what people know and what they can do, and we can teach them. But it's not always easy, and the funds are always an issue. It's never that there's a lot of money.
Can I add another point there?
Yes.
Sure.
So, yeah, the other thing I should maybe mention is, you know, what I've seen in historical buildings here in the Cape is with the more wealthy kind of buildings and prestigious buildings, then you would find lime plasters. And these buildings, as I say, they last, you know, indefinitely. If you maintain that plaster, and often the paint, you know, it's not just the plaster, then you lime wash and you renew that lime wash. Now, in modern days, and those buildings last. If you were not so wealthy, then you wouldn't afford the lime plaster. Then you would just have an earth plaster. They would typically add cow dung because cow dung has casein in it, and casein is also a waterproofer. So, and it helps to kind of set a bit. So, and it's also got all the fiber, which is pre-digested and so on. So it's a very good addition to any plaster. In fact, we add it to our lime plasters, makes the lime plaster superior. more waterproof and easier to work, and less prone to cracking. But yeah, typically you would just, if you didn't have the money, that you'd find these older buildings were just earth plastered with cow dung in that mix, and then they would lime wash the buildings. And if they just lime washed and renewed the lime wash, the buildings again would last indefinitely. And that's a much cheaper finish, obviously. And these days you have the option of breathable paints. So you have membrane paints that prevent water coming in, but they allow water vapor out. So this takes it into another thing. So I've done buildings where we've just done clay plasters, cheap, easily done, and then we apply a breathable paint, and you'd never know, you know, and they perform, and it's at a fraction of the cost. So, yeah.
Thank you.
Great, thank you for that. Felix, I believe, who's our architect here, he has some questions.
Yes, thanks. Good evening, everybody. Thanks, Andy, Eckhart, and Peter for really interesting presentations. I think we are all, I can see that in the comments, everybody's really interested. And I really enjoyed the fact that we have looked at, or we are looking tonight at straw from really two different angles. That was our idea for this presentation, so that we see it as a versatile construction material, just like many other construction materials also have different applications. So I want to thank all of you for your contributions. I noticed there are questions from many people, so I don't want to ask too much, but I do have questions for both of you. Andy, quite simple questions. I think everybody asks simple questions. You know, I saw many questions around water, which I think you've addressed in many ways. You've got some very interesting details at the lower level of the wall that I was very interested to see. You know, your ladder, I forgot how you call it, but you know, basically the gravel-filled little framework is a fantastic way of, as a GPC, that works really well. You mentioned that how well this stuff performs with fire. That's a bit counterintuitive to me. Can you? I'm going to ask you more than one question, so maybe just okay. Say one word why that stuff doesn't burn like hell. A second typical question that many people have, and I'm asking on their behalf, is well, people with sort of allergic tendencies. Is there anything about a straw? You know, a straw bale building that you would want to be nervous about, or you should be nervous about. A simple practical question is, can you hang a picture on the wall? I think that's also kind of interesting for many people to know. And lastly, I just wanted a clarification. I really like your idea that, you know, that technique that you've developed of you know, of dumping the bales into that yogurt like, you know, mix. Is there lime already in that mix? Am I? No, not at all. Okay, but maybe you can just say a word or two about how that mix works. Overall, I really thought what I found interesting about your presentation is that, I mean, you focused a lot about, you know, how it's done. You didn't have enough time, and therefore I saw lots of pictures of projects sort of flying through the screen, and I'm sure that everybody would absolutely love to see that presentation in their own speed, because I think what I saw is that architecturally speaking, there's a lot of variety. So, you know, people very often think, when they hear of straw bale buildings, they think more of sort of the curvy, cobby, you know, structures that you do see. But I think you can also really create a completely contemporary architecture, and quite, you know, also quite simple buildings if you want, that do not necessarily show you know, how they are built. So I find that a very interesting aspect as well. So I would really love to see your presentation with a bit more time. I'm just going to throw out my questions to Eckhart as well, and then you can just answer one after the other. One very interesting aspect that I would like to understand more about is how you what is sort of the standard detail that you use at the bottom of the panel. I sort of understood how the corner works, and I understood how how the ring beam works, but I think it would be very interesting for us to hear what you recommend, or how the buildings that you are building with your panels, what happens there at the bottom in terms of, you know, in terms of fixing detail, but also in terms of moisture protection. And then as a second question, a bit similar, I'm sure you've thought about it, I'm sure you have an easy answer to it: services. Are there any nice ways of getting conduits into this stuff? How am I running my services down the walls? Simple question. Thank you very much.
Okay, so to answer the first one about fire, so basically fire needs, so I should actually correct that. So during construction, when you are retying the bales and you have a lot of loose straw around, that is a big fire risk. So you have to have fire precautions, no smoking signs, and fire extinguishers at hand, and so on. You have to sort of, so there is a risk, as I say, and you have to have tidy up. So you've got to tidy up at the end of every day, or every lunch or break or whatever. You got people sweeping up all the loose straw, because the stuff just generates at an alarming rate as you're retying and work and handling the bales. But essentially, it's about compaction. So when you have enough compaction, it's like timber. It doesn't burn, it chars. So there's not enough oxygen to support the combustion. And then because of the high insulating value, and now you've encased it in clay, you know, as I said, it's phenomenal insulation. So the heat doesn't transfer through. Normally fire works by, it spreads through radiation. So it just radiates through the wall, and the temperature reaches a certain height, and it just ignites all the flammable stuff, and then that starts your fire, spreads. You know, it spreads through walls like that. Whereas here, the heat doesn't even get through the wall. So in 2 hours, you only had an 8-degree surface, you know, temperature transfer of 1,000 degrees on the one side, and it was only 8-degree difference on the other side of the wall. I mean, what wall can do that? Only Strawboard or Strawbell, I think. Something super insulated like that. So yeah, and then allergies. So yeah, if you're working with the bales and you've got allergies, that's an issue. So people do wear masks and so on, but yeah, you may not. It may not be for you to build with if you have a lot of straw allergies. But once it's plastered, of course, then you know it's sealed in there and so on, so it's fine. And hanging a picture. So if you do the method like you saw there with a solid sort of pre-coating, dipping of the bales, and then getting that slip to harden, you know, you're ending up with about 70, 80, even 100 mils of solid cob or fused, where the clay is fused with the straw and set rock hard. So you've got two outer skins of almost 80, 90 mil or whatever. So that, and then plaster. So you've probably got about 100 mil to drill into. And if you've got very hard, like heavy shelving or whatever, then you typically kind of build in timber supports, plugs or what have you, vertical ladders, whatever it might be. You know, you kind of you make timber things that you prefix. You can also even knock wedges in afterwards, or even round sticks, and then just cob solidly around. So if you're kind of wanting a heavy hanging, and you can do that even after the fact. And then lastly, lime. So that in that dipping mix, it's typically just so a normal slip is almost pure clay, and the silts and sands fall out. So what we try to do, we build with a kind of cob mix. So it's a blend of sand and silt and clay. So it's about typically 15, whatever, depending on the stickiness of the clay. So I shouldn't even give you a percent. It's just about not too much clay that it cracks, not too little that it can't stick. So you're kind of looking for that optimum of maximum stickiness without cracking. So you can take that testing down to a very fine art for plasters to get the mix just perfect. But for this kind of thing, it's just very quick testing. So it's just more or less right. You know, it doesn't have to be perfect, because you're still going to finish it in the final layers. So, but I go for that, and then when you have that mix, you've got to kind of stir it up, and you mustn't just let it sort of separate out, and so you want all those sands and silts in there as well, so that when it sets, it's not going to be sort of weak and crack up with all the, if it's all clay. So it's that blend that you'd have of a cardboard adobe mud brick kind of set. So it's strong in the end. Yeah.
Thank you.
Great.
Eckhart?
Yes, Felix. Yeah, so I can confirm also what Andy said, and we've looked at Strawbell construction as well. When it comes to fire with our panel, we've done a lot of testings in Europe, in different institutes, and different kind of walls. And the result was between 60 and 90 minutes. We have a 120-minute wall solution as well, but for the strawboard. And it's exactly what Andy said, that it's compressed so much that there's no oxygen to feed the fire. And it's kind of like taking a very thick book and tying it up and throwing it into the fireplace. It will still be there after hours. Yeah. And when it comes to hanging pictures at the strawboard, with the strawboard, we've done tests. So with a normal wood screw, can carry 80 kg per screw. Yeah. So we have, for instance, TVs or some kitchen cabinets that are being hung on the wall. If it's a 2-panel wall, that is not an issue. Yeah. You asked about the detail at the bottom. So there's an array of different options, and you've seen the building in Addis, and I didn't tell anyone about it because I thought it will not last for 6 months. And now it's 8 years and I can talk about it because the professors decided to just use stones, local stones, put them down and put the strawboard on top of it as a slab. Yeah, there is no concrete underneath. There's nothing. There's air in between the surface of the ground and the slab. And you might have seen on the strawboard, they then fixed little L profiles and attached the walls that go up. There are some anchors that hold it down in addition, but they have used some casein. We talked about that earlier, or Andy did. So we've done a lot of tests with different mixtures of casein to see which one works well to protect from water. So they have used that. But that's the simplest and simplest solution. What we now do is we use typically we use a U profile. So it's 12 centimeters and I think 6 centimeters high, and it's continuous. We seal the joints between the profiles, and we put tar paper into the profile and then paint the strawboard with this latex paint on the bottom, and that prevents any humidity coming up. We fix the board with screws to the profile, and the profile is fixed with bolts into the foundation. There can be different foundations, so there have been very simple ones. At the moment, our clients, they are Germans. They don't want to see a little crack in anything. So we have to build quite high quality, but it is something that can sit on any kind of foundation. I mean, the key is again, in the north, we sometimes have heavy rains and there's a lot of flooding going on. So what we do is we build little wall bases that are 15, 20 centimeters high. And then on top of that, we put the strawboard construction to have it out of, not just about 20, 30 centimeters out of the ground with the slab, but then an additional 20 centimeters of the slab. Yes, and that was also something we did in the beginning because a lot of the typical cleaning process there is you take a bucket of water and dump it in the building. So everything gets soaked. And initially we built these little wall bases to protect the board from that, but by now we've also found that the profile together with a what do you call it, around the floor, the baseboard, if you will, but yeah, that protects it as well. And the last question was about the services. So we can produce the panels with and without conduits. So they are 22 millimeters. It's basically made for electrical wiring. And depending on the project, we in the production process, we already produce it with or without the conduit. Yeah, when it's a wall that has a lot of pipes in it, what we typically do is we take the panels, take them apart, and have a void in between. That's whatever we need, 6 centimeters or 8 centimeters, and run all the pipes there. In a hospital, we have actually once had that about 40 centimeters and accessible with little doors, because they wanted to be able to run through more channels and more oxygen lines and so on at a later point. And because the panels don't need a framework, it can be open between the two walls. Yeah, so that was an advantage over gypsum board, for instance, where you have a frame and then they can't run cables through later. But in this case, we built 2 single panel walls with a distance of 40 centimeters to run services through later.
Cool. Thank you.
Great. Thank you, Andy and Eckhart. And thank you, Edson and Felix, for the questions so far. We are now going to move on to the questions in the Q&A on Zoom. And just browsing through this, a lot of them have to do with weather. So I'll just group them. I'll read them out in groups. So there's one from Natalie Nachtende, who basically had a concern with straw in terms of water and rain rain climatic conditions. And one from an anonymous attendee who wonders about the performance of the straw boards or panels in flood-prone areas. How can they be treated to withstand such conditions, considering that Uganda's climate is hot and wet? And actually, to add on to that, are they even feasible? Is this material even feasible for flood-prone areas?
Okay, shall I say something about the flood-prone areas? I mean, I just addressed that with Felix and mentioned that in these areas we typically build a wall base out of concrete or whatever, and have that way get the strawboard out of the areas that are flooded. So it's not a problem. I mean, Uganda doesn't have more rain than Ethiopia, for instance. It's not a problem with the rain, as long as we protect the outside, as I mentioned. We've never had an issue with that, really. The key is, yes, if there's flooding, and the flooding is not just temporary. So we've had a building here in Germany that was flooded, and there was water in it for a day and a half, and about 50 centimeters high, and the strawboard soaked up with water. Yeah, but then the water was gone and it dried out again. So that works. But ideally, we take it. If that happens often, it's better to take it out of the flooding area.
Okay, perfect. Andy, do you have anything to add to that? How do the Strawbells work?
Yeah, only just that point about what we'd call a toe up, so that the main danger of flooding, certainly that I've seen, is more from mopping, spilling a bucket of water on the floor. And I had one project where we're actually in a floodplain area. We built, so the council made us build the floor level a meter higher than the natural ground level, so we were already raised up. But sure, if those walls were to have been flooded and stay wet, the straw to stay wet for any length, if it's kind of a flash flood and it drains off and it can dry out again, that'll be okay. But if it stays sort of solidly wet for any kind of prolonged period, then it will rot. So in this case where where I mentioned we built up on the floodplain, it was an owner builder, and they thought, well, this is high enough. So they ignored the toe up from the inside. So, so of course, and then it was too late. By the time I spotted it, the client said, doesn't bother, he's just gonna carry on. So of course, 5 or 10 years later, what it is, the bottom of the bales from mopping as predicted, because there was actually, the walls ended up being lower than the inside floor level once the screed had been cast. So that was a problem in the bottom. And so what ultimately happened was that that bottom did start to rot. And, you know, you could sort of see there were issues. And so you actually had to underpin the whole structure. So you kind of put temporary props through the wall, pushed these kind of beams through the wall, little purlins or whatever, and propped up the whole wall and put new bales into it. Built the toe up in timber, treated timber, and put the gravel in that wasn't there before. And it was one of the early buildings before we were doing that detail. And then put the bales back in, plastered up. It was good as new again. But so it is. What I kind of want to say is these materials are surprisingly repairable and forgiving. And you can recycle that clay. You just remix it and put it back in with some new straw. You can, so it kind of, the fusion between cob, light clay straw, and just pure straw is kind of, it kind of accommodates all permutations, and it's very kind of interchangeable. Yeah.
Fantastic. And I know actually on that point about the plaster and the clay, you know, despite it being a very forgiving material, like how often on average have you found that you have to maintain it or replaster?
So basically, if it's done right, you know, one doesn't have to kind of replaster. Just you've got to make sure that paint is kind of maintained if it's a breathable paint. But I have seen, again, you know, where people didn't maintain their sills, their window sills, for instance, and their tiles dropped. They did some tiles or something, and they just did a single layer, and it sort of dropped out, and then just kind of left it. You can't do that with a Strawbell building. You can't just kind of leave it to deteriorate and let the water get in, because the damage will be quick and more extensive. So when you have a problem like that, but it's localized, and you can go in and fix it locally, you know. So I have had cases where that's happened and they didn't attend to it. So you've kind of got to go and rip out the part of that wall if you've got some kind of damage there, and then just put new material in again.
Sounds good. One of the questions here, and I think George had directed it to Eckhart, but I'm actually pretty curious. So I'm going to direct it to both of you. What is the cost per square meter of the materials, of the Strawbells and of the panels for Eckhart?
So if I go first, then I'll just, it's very difficult to kind of pin a figure on it, but because we're not really, it's not like we're mass producing lots of buildings and sort of larger scale projects where we have quantifiers that can kind of isolate the costs for us. So it is pretty tricky. But what I would generally say is a lot depends on the process, and where a lot of times you have owner builders or communities doing the wall part of the building. So they have normal contractors doing the foundations and all the normal stuff, the roof, electrics, plumbing, etc. And then the community or owners step in and then they build. Then they can actually save money. But where you've got a, and sometimes also it allows, because it's a kind of simpler way, it does allow owner builders, although that has its own problems. And if you don't count the cost to the owner themselves of their labor or their time out from their work, or earning capacity, if you sort of see that as free labor, then, you know, people save a lot of money like that. But if you get a conventional contractor who's they've got to keep their eye on the ball, even though so generally I either found the contractors will say, well, we save a lot in material, but we've had to add extra cost for our labor and attendance to the job because they've got to keep a much closer eye on it because we don't have standard teams, or it's not a conventional method where we're building loads of these and have teams with all prior experience. So, you know, so then they will either cost it typically at a same cost as it'll work out to be the same, or sometimes a bit more even with a conventional contractor. But you're getting a thick, very high quality wall, actually healthy and super insulated.
Great, thank you. Eckhart?
Yeah, so the Strawboard it costs about $15 a square meter, and when you look at construction, the advantage is that you can build much faster, so you save some labor cost. You don't, when you build single story, the panel is actually the structural part as well, so you don't need reinforced concrete columns and then fill it in and so on. So it depends. When we are in the countryside, it's clearly cheaper to build with roadside bricks because there's no cost for the wool, for the wood that just gets cut. The soil is taken out of the ground, so it's just labor cost basically, and the cost for cement in the mortar. But when it comes to the environmental impact there, you know, it's also a big question mark because society has to bear the cost later when there's no forest anymore. In cities like Kampala, it's competitive. We are doing a number of projects. We are just designing a new project. It is a 3-story building that has a conventional reinforced concrete skeleton, but the external walls and internal walls, everything, and ceilings are all out of Strawboard. There we try to make the concrete better. So we work with the BAM here, with the German Federal Institute of Material Research and Pete, on introducing a bioconcrete in Kampala. So we have we are looking at adding rice husk ash to replace cement in the concrete, and thereby again create a local value chain. So the rice husk that is there at the mills and its waste can actually be used to fuel a process of making food or whatever, and we can then use the ash again for the concrete mix. And that is something that has been tested over the last few years already, and it's quite advanced, and we hope that we can actually introduce that next summer in Uganda.
Great, thank you. There's someone who raised a hand, Petrina Salema. I'm just going to allow you to talk so you can ask your question.
Hello, can you hear me?
Yes, you can.
Okay, so first of all, Petrina gave me this link. So my name is Edgar.
Oh, hi, Edgar.
I'm sorry, maybe I was not well coordinated, so I posted my questions all over in case you guys hadn't seen them. But they're basically the ones that says in terms of the biggest city, someone mentioned the biggest city being in 2050. So how do you think this technology will influence this city or will actually promote good sustainable design and development in this city in Africa in 2050? And then the other one was how far up in terms of, if you look at growth of cities and how cities, well, as urban designers, I think they do not promote horizontal expansion, you know, in terms of sprawl, but they try to keep them compact because then that's how you'd end up with, I think, sustainable and cities where people can walk and live and do things within a small radius. So how high can these technologies go in terms of like maybe 30, 40 stories where you can actually have replace or come up with arguments that can replace office buildings and can replace, you know, the modern day contemporary glass structures, and then like implement, even if you'd have to use timber for the structure to also sustainable timber to support with the carbon retention and all that. And the last one is how can you market then this technology? Because I think another challenge we're facing is the architects who are currently in school. I graduated recently. We live with all these contemporary, you know, modernist or postmodernist type of design in our mind, and that's what we want to create. So if we get an idea for designing a school, we want it to have glass windows and all the fancy stuff, not necessarily looking at sustainability and, you know, easiness of acquiring materials. So how would you say you would market such a technology to maybe contemporary architects or younger architects, and even so to students, so that even when they embark on projects that are within an urban context or for public buildings, even private residential buildings, they're more inclined to suggest ideas such as straw boards and straw bales, especially where the material is available. Like in Tanzania, for example, where I'm from, I did go to a village where they were using the rice husks to burn the burnt bricks. So instead of using wood, instead of cutting down trees, they now use, because in that region, in Ifakara, they produce, it's like one of the major producers of rice in Tanzania. So then they just shifted instead of to save the forest, now they're going to use this waste material. And before I went there, I did not know that. In my entire 5 years of studying architecture, no one mentioned such alternatives. So every time you think of burnt bricks, you think, okay, I need to find a place, firewood and stuff like that. So how would you maybe inject these technologies into universities and to, like, you know, upcoming students so that they actually want to do that as well? Thank you.
Yeah, so maybe I start. There were a couple of questions, and I think this could be a whole 2-hour discussion minimum. But first of all, the idea to use rice husks to burn bricks is actually something we've been looking at as well. We've measured the temperatures, if it burns at the right temperature. We've even mixed it with our sawdust from the strawboard's production. You know, the dust that comes out of the straw, and found that the mix of rice husk with our straw dust can actually fire brick production. So that's a good thing. And I think, you know, it has to start with the students and at the universities. It's a long-term process. You won't change the mind of people who are like 40 or 50 today. Yeah, they want their bricks, and you can talk whatever you want to talk about. It will not change, I think. You know, they might say, oh yeah, others can use it, but I build a house for myself, I use bricks. And the young generation has to look at that, and you are the ones who will live in these cities in the future, and can shape it. And I think it takes people like you, just graduated and interested, and you ask the right questions, to then take it back to the university and maybe engage with people like Felix and us and so on to get us in there to spread the word. So what I can see is, and it's very clear, you know, there is an optimal height of buildings in urban centers. So 50-story buildings are not ideal when it comes to the usage of material. There's a clear correlation between when it suddenly goes through the roof. And I think, I'm not an engineer, but from what I've read, it's somewhere between 10 and 15 stories. Yeah, and there's no reason why we can't build these buildings with better materials than today, and why we can't replace the infills, if it's externally or partitions, with other materials like the strawboard. Yeah, and we are actually currently working on a sandwich kind of panel strawboard with other materials that can be used in Europe to build buildings. Here's the focus is up to 5 stories structurally, and there's a lot of opportunity, and to create these local value chains. Yes, you won't get around using some concrete, but you can make the concrete better. You can use less cement. You can use local additives instead of things that are made from oil that's sent from Nigeria to China, then back to Europe, and then comes to Africa as an additive for a ridiculous price. And but it takes people locally to really engage and make that happen. And I'm very happy to share any kind of ideas I have and to support things like that if I can. But but we have to start somewhere. And I think this local talk today is one of these points where things start, because you all hear about this and you think about it, you come with good questions and maybe good ideas how to use it and how to improve the design and the technology. And that's what we have to do, you know. It's and it's not just about strawboard or straw bales. It's really all materials that allow us to build sustainably, that can ideally be produced in a local value chain. That's what we have to focus on. And when I look at timber, you mentioned timber, and there is someone in Cambridge, actually, Michael Ramage. He's a very good guy. He's very focused on timber. There are some videos you should look at, is engineered timber. And I've actually worked with him on something in Rwanda some years ago. You know, that is something to bring in, and people of that level need to join the process there. And I know that his focus now is a lot on, you know, the much bigger markets at the moment, and get that implemented in Europe, and it's happening more and more. Engineered timber high-rise buildings are coming, but it's something that can be done locally. And the same with FSC certified timber. There is there's several managed forests in Uganda, yeah, but they can't request or demand a premium, although they deliver a better product. You know, they replant, they manage the forest, it's certified, but they have to compete against timber that's just being cut somewhere illegally and cost not much. And that's the issue. And that's where also donors and you know, international donors have to come in and say, when we finance something, or banks, it has to be environmentally friendly and sustainable. And the material now, you know, everyone is looking at solar panels and energy and hydroelectric energy and so on, but not many people looking at the materials. And I think that is now the focus you have to have. And a lot can be done, and I don't see why we can't build 10-story buildings using technologies like the ones we are discussing this evening.
I think some good points. So just to add, obviously straw bales themselves, if you're building with bales, you have that thickness. So it's not. I think the main thing is you know. There's no silver bullet. There's no one solution. It's a bunch of solutions, and it's just another arrow in your quiver, so to speak. And it all depends about what makes sense in the context and what you're trying to achieve locally. But I agree. For me, it's very much about that creation of local value chains and using being more self-reliant on what is local, and so whatever that might be. And So that's why I also showed the light clay straw, which is a kind of hybrid, or it's a slightly different method, which allows for thinner walls, but it is more timber heavy. So you're kind of got to weigh these things up. And yeah, I think in terms of sort of promoting these types of materials and so on, I think it's a mindset, and definitely the students. And having, you know, is where it's going to grow from, the younger generation. And so it's having talks like this is very much, I think it's important to create dialogue and raise awareness, because I think that's, you know, unfortunately these types of industries aren't typically, you know, don't have the clout of the big cement industries and the big kind of petrochemical based materials. I mean, they advertise a lot, and they'll tell you how green their polystyrene blocks are and so on. So we can't really compete with that. But I think on an intellectual level and on a sustainable level, if people really want to engage in sustainable practices, then you know, it doesn't take long to when you start looking at these materials, then you realize, yeah, these are solutions. Whereas you look at kind of the marketing of some of the so-called greenwashed products out there, they're not so green, you realize, and they're still heavily based on the petrochemical industry or or cement products. You know, I think we have a way too many. We you know, as architects, we just tend to think of form and instead of material, and how that informs form and our forms that we make. And the climate and how it affects the climate. And when you start to take on those other factors, the social factors and everything, then one's understanding of material changes, or response to the form that you're going to make is informed more from the materials you have around you and the process which you're going to engage in to build, more than the design and then, okay, what material should we use for this design?
Great, thank you both so much. I think we are about to close. And just looking through the questions, I think in one way or another, all the questions have been answered. So thank you for that. I will just invite, oh, Peter, did you have something to say? I see your hand is up.
Yeah, if I have the time, just from a structural engineering point of view to add to what Andy and Eckhart were just saying regarding densification of cities and megacities. One thing is, it is for sure that we will have high rises in these cities, whether we like it or not. Even if there is a sweet spot at 10 to 15 stories, material-wise, we will see higher buildings, whether we like it or not. In terms of the materials that we're just discussing here and their use in high rises, just basically speaking, the two challenges when building a high rise, surprisingly, is not the vertical forces, it's not the height of the building itself. It is earthquake and it is fire safety. So we heard that these materials have no problem in terms of fire resistance. And in earthquake, they actually are very beneficial, at least the Strawboards, because they reduce the overall weight compared to hollow block, concrete hollow block structures that are currently used. So we can save actually on the load-bearing structure by lighter infill walls made from these kinds of materials. But there is a limitation to that as well. That's why the really high buildings, they don't use heavy partition walls, even in conventional structures. They use element walls and drywalling. So for the drywalling, it's an equal substitute or a better substitute. And for the element facades, we were thinking about that as well, because as much as we like Andy mentioned, and I completely agree with that, we like to use the materials at hand to the best function, and we also need to think about providing an industrial product for conventional approaches, because still this is the majority of the structures we're seeing in the cities, and I think we should think about providing solutions that are easy implementable in conventional systems. So that's why we're thinking about element facades made from Strawboard, for example. They can substitute sandwich panel facades or something like that. So just that's from the engineering point of view, not contradicting what Andy and Eckhart said before. Thank you.
Thank you so much, Peter. We're gonna have Felix to give the closing remarks as we wrap this up before curfew over here. So Felix, please go ahead.
We still have a bit of time, but still, it's been a long session. It's been a bit longer than we thought, but I think it is partially just simply because it's a very interesting topic, and we've had lots of engagement, and that's always a good sign. I've learned many things, and it's not always easy to. You wouldn't boil that down into a short statement, but I'm just going to share you sort of share with you what went through my mind while I was listening to both presentations. Is that previously I had always thought of straw as this, of course, this particularly well insulating material, which it of course is. If you think of straw bales, there's 0.5 meter thick walls. They have a phenomenal insulation property. This is of course not something we're actually looking for in Uganda, funny enough. We are living on the equator where the temperature is always between 20 and 24 degrees and never changes. We're not that that particular about insulation. So it always went through my mind, this question. I'm interested in it, and then thought, but is it really the right thing? Is it what we want here? Is it not the very heavy core and a relatively light facade around it that allows air to pass through a building? But what I learned tonight, or what really sort of became very clear to me, is that there are so many other interesting aspects of straw, way beyond that one aspect of insulation. And you know, just to mention, of course, the few obvious ones, it is of course completely renewable. We are not burning anything. We are not using wood. We are basically using a byproduct of agricultural production. This is of course in itself already an amazing aspect. One thing that I think Peter has just mentioned, which is also really interesting, it's lightweight. This is we didn't talk so much about it, but I think this is also something that of course causes far lighter foundations, far simpler building around the walls, because you simply have a very lightweight material. It's local, it's natural, it's healthy. It is relatively low skill. So we as Local Works are very keen on trying it out. I must say I am very keen on the straw bale. I appreciate that Andy has also talked a little bit about the light clay straw idea, which is also something we're interested in. But of course, one thing I like about the Strawbell technology is that you do not need to shutter. And shuttering is always something that sort of, is material, it is time, it is labor, it is cost, it is all sorts of things. It's kind of beautiful just to be able to stack up a material. So I quite like that whole aspect of Strawbell construction. Those are my very short closing remarks around the topic itself. For Local Talks, it's going to continue. It is going to remain, at least for now, a quarterly affair. It is going to probably remain online. That was not our idea initially, as you can imagine. This is actually the first one where we decided we'd do it completely as a webinar. In the beginning, we did some kind of hybrid. Let's hope that in a year from now, or whenever the pandemic is a bit over, that we can meet face to face, so that we can have also some practical engagements. That's something that Local Talks was always about. We do not know yet what the topic is of the next session, but we know the date, because it is always the third Wednesday of every third month of the year. So whatever that is in March 16th or whatever it may be, we will obviously inform you. And if any of you, literally any of you, has an interesting idea or a question or a proposal or somebody they think we should bring into this forum, please don't hesitate to send us an email and let us know. We are always interested in basically providing the forum for an interesting debate that has more than us as the interesting members in it, which I'm very happy to say we seem to be achieving. As my last comment, I want to thank Sarah. Sarah has said this is her last session. I want to thank her for all the work she has done for Local Talks, helping setting it up and helping running it for this year. And I can already tell everybody that we have a very, very able and skilled successor for Sarah, and we will present her to you in March in the next session. Thanks a lot from my side, and Sarah, probably you close the session.
Yes, thank you everyone who showed up today. Thank you to our speakers, Andy, Eckhart, and Peter, and for the amazing questions from Edson, Felix, and Edgar, who actually spoke, as well as the people who sent through their questions in the Q&A. I had a quick look on Facebook, and there were no burning questions, so I think everything is handled. As we normally do, we will be sending you an email of the replay of this session. So I know that was a burning question in the Q&A. You will be able to review this at your own pace, or alternatively, you could simply look for the Local Works page on Facebook, and the video will also be saved there because it was streaming live on there. So thank you everyone for showing up, and we hope to catch you on March 17th, 2021. Have a lovely holiday and stay safe.
Thank
Bye.
you.
Right. Thank you.
Thank you very much. Good night, everyone.